welcome you all to Think Max. We are in class 11 Max, chapter 1, sets. In this session, we are going to discuss about the example problems 12 to 19. So these examples are based on operations on sets. They are union, intersection, difference. So first example, that is example 12. A is equal to set of all 2, 4, 6, 8 and B is equal to set of all 6, 8, 10, 12. We have to find A union B. So what is union? Union is nothing but set of elements in A and B are both. Okay. Set of elements in A or B are both. Okay. Now check the elements. In A we have 2, 4, 6, 8. In B we have 6, 8, 10, 12. So here in A union B we should not repeat the elements. Now if you check the elements in A and B, 6 and 8 are both in A and B. It should be written only once. So therefore A union B equal to set of all 2, 4, 6, 8, 10, 12. So this is A union B. Okay, children, I hope you can understand this. So very simple. Just you have to write all the elements in A and B, and the elements that appear in both A and B should be written only once. Okay. So moving on to the next example. Example 13. So A is equal to set of all A, E, I, O, U and B is equal to A, I, U. What we have to find? We have to show that A union B is nothing but set A. So if you check the elements in A and B, in elements A we have vowels A, E, I, O, U. So what are the elements in B? It is A, I, U. So A, I, U. All the three elements in B appears in A. So therefore A union B. So whenever you write A union B, first write all the elements in A. A, E, I, O, U. So next you write the elements in B. But in B, all elements in B are in A. So already A is here, I is here, U is here. So no need to write those elements again. So this is A union B. So A union B is nothing but the set A. So it is A. So therefore A union B is equal to A and it is shown. Okay. So moving on to the next example, example 40. Let X is equal to set of all Ram, Geeta, Akbar be the set of students of class 11 who are in school hockey team. Let Y is equal to set of all Geeta, David, Ashok be the set of students from class 11 who are in the school football team. Find X union Y and interpret the result. So X union Y. So there are students of class 11. So who are in hockey team or football team or both. So now if you check both, Ram, Geeta, Akbar, here Geeta, David, Ashok. So only Geeta appears in both X and Y. So Geeta should be written only once. So others are written once. So Ram, Geeta, Akbar. So these are the elements in X. We have to join with the elements in Y. In Y we have first Geeta. So but Geeta is also in X. So no need to write that. Next we have David, Ashok. So they are the students in Y team. So join with this. So X union Y is Ram, Geeta, Akbar, David, Ashok. So who is X union Y? They are the set of students of class 11 who are in school hockey team or school football team or both. So Geeta is in both. Okay. So Ram and Akbar are in hockey team. David and Ashok are only in football team. Geeta is in both. So interpret the result means we have to write the result as, so this is the set of students of class 11 who are in school hockey team or school football team or both. So this is the way to interpret the result. That is, what does X union Y says. Okay. So moving on to the next example. Let A is equal to set of all 2, 4, 6, 8 and B is equal to set of all 6, 8, 10, 12. We have to find A intersection B. So this symbol says intersection. So we have to find A intersection B. What do you mean by intersection? So the elements in both A and B. Here and B, not or. Okay. So and B means you have to take the common elements in A and B. So who are common? Is 2 here? No. 4? No, it is not present in B. 6? Yes, it is present in B. What about 8? Is present in B. So A intersection B is nothing but 6 comma 8. It is very simple. There is no calculation. Just you have to look at the sets and find out which is common. Okay. So moving on to the next example, example 60. So this is from another example. So in example 14 we saw this x and y. So consider the sets x and y. X is nothing but set of all Ram, Geeta, Akbar with set of students of class 11 who are in school hockey team, and y is equal to set of all Geeta, David, Ashok with the set of students of class 11 who are in the school football team. What we have to find? Here we have to find x intersection y. In 14th example, we formed x union y for the same set x and y. Here x intersection y. Who is common here? Yes, you all know that Gita. Because in the 14th example, we wrote Gita only once as it appears in both the teams. We wrote Gita only once. So this is the common element for both Gita, both X and Y. So X intersection Y is Gita. Only common element should be written inside the set. Okay. So X intersection Y is nothing but set for Gita. Okay. So there is this Geeta is in both school hockey team and school football team. Okay, children. So moving on to the next example, example 17. Let A is equal to set of all 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and B is equal to set of all 2, 3, 5, 7. Find A intersection B and hence show that A intersection B is equal to B. So now we have to find out the intersection, that is common elements in both A and B. So let us check. 1, is it present here? No, it is not present in B. 2, yes, 2 is present. 3, it is present. 5, no, next check 4, no, it is not present in B. 5, it is present in B. 6, no, it is not present. 7, it is present. So no need to check the other elements because we have completed the sets in B. So there are no other elements in B. So these elements 8, 9, 10 is not common. So A intersection B is equal to 2, 3, 5, 7. So set of all 2, 3, 5, 7. Who is this? It is nothing but the set B. The set B is also set of all 2, 3, 5, 7. So equal to B. So A intersection B is equal to B. Okay, children, because A is a subset of, not A, B is a subset of A. All the elements in B is in A. So we will get A intersection B is equal to B. Okay, children. So moving on to the next example. Example 18. Let A is equal to 1, 2, 3, 4, 5, 6. B is equal to 2, 4, 6, 8. Find A minus B and B minus A. That is, we have to find out the difference. Okay, first we are going to find A minus B. What do you mean by A minus B? It is the set of elements in A but not in B. Okay. So we have to choose the elements in A. It should not be in B. So 1. Is 1 in B? No. So write it here. 2. Yes, it is in B. So you should not write 2. Next 3. 3 is in B? No. So we can write here. 4. Yes, it is in B. So we should not write. 5. It is not in B. So we can write. 6 is in B. So we should not write 6. So A minus B is 1, 3, 5. Okay, children? So that is the elements in A but not in B. So here if you check, 1 is not present in B, so we can write 1. 2 is present in B, so don't write it. 3 is absent in B, so write here. 4 is present in B, you should not write. 5, it is not present in B, we can write. 6 is present in B, you should not write. Okay. So next one, B minus A. What do you mean by B minus A? That is set of elements in B but not in A. So we have to choose the elements in B. So let us choose. 2, yes, it is present in A. So don't write. 4 is present in A. Don't write. 6, it is present in A. Don't write. 8 is not present in A. So we can write 8. So A minus B is equal to set of all 1, 3, 5. B minus A is equal to set of all 8. It is called a singleton set. Only one element is present. So it is called singleton set. Okay. So moving on to the last example for this session. Example 19. Let V is equal to set of all A, E, I, O, U and B is equal to set of all A, I, K, U. Find V minus B and B minus V. So very simple. We have to find first V minus B. So as in the previous example, we know that V minus B is the set of elements in V but not in B. Okay. So V is nothing but vowels A, E, I, O, U. So let us check. Is A present in B? Yes. A is present in B. So we should not write. E is present in B? No. So we can write. I, yes, it is present in B. So don't write. O, no, it is absent in B. So we can write O. U, yes, it is present in B. So don't write it. Okay. So the elements in V minus B is E comma O. These are the elements in V minus B. Next, B minus V. That is the set of elements in B but not in V. Let us check. Is A present in V? Yes, present. Don't write. I present in V? Yes, it is present. Don't write. Is K present in V? No. So write it. U present in V? Yes, it is present. So don't write it. So only K. It is a singleton set. So these are the elements in B minus V. So with this, I hope you can understand what is union, what is intersection, and what is difference between two sets. So in the previous videos we saw about the concepts in union, intersection, difference, that is introduction to exercise 1.4. So these examples are based on the exercise 1.4. So if you are able to understand all the topics in this, then you will be very easy to solve the problems in exercise 1.4, which we will solve in the next video. So if you are able to follow my classes, just show your support by hitting the like button, and if you are a good student, just share among your friends and relatives. Also show your support by subscribing to Think Max and hit the bell button so that you get the notification whenever I upload my videos. Thank you.